All right, guys, we're going to talk about lesson 5, which is writing chemical formulas for ionic compounds. So, recall chemical formulas. So, remember, coefficients go in front of the formula. The small number after is called the subscript. The subscript after the parentheses means you need to multiply everything inside by that number, and the number of atoms in each substance in the formula above. So, for this, we have 2 CAs, 2 Ns, and 6 Os. So, what are oxidation numbers? Oxidation numbers indicate the number of electrons lost or gained when a formula is formed. So, on your periodic table, you have the most common oxidation numbers that those elements can have. So, when you write a chemical formula, the sum of the oxidation numbers has to equal 0. So, Na is plus 1, Cl is minus 1, so plus 1 plus a minus 1 equals 0. So, let's look at some writing formulas. So first, you want to write each ion, the metal goes first. Then you're going to crisscross and reduce the oxidation numbers, not the signs. And then you're going to write the numbers as subscripts, and then we do not write ones. So these are the 4 basic rules that you need to understand. So metal comes first, then nonmetal. You write their charges, you crisscross them and reduce, and then you write the number as subscripts. So, example, the compound containing magnesium and chlorine. So, locate those on your periodic table. Magnesium is going to be plus 2. Chlorine is going to be minus 1. So, what we're going to do is we're going to crisscross the charges. And those charges are now going to become subscripts, but you drop the plus and minus. So, when we do that, we get MgCl2. Notice how this 2 is now the subscript for the Cl. That 1 is the subscript for the Mg. We do not write ones. And so Mg, magnesium, and chlorine will come together to make MgCl2. So why does this work? This works because what happens is that these 2 outer electrons from magnesium are going to be given away to the chlorine ion. And when they're given away to the chlorine ion, Mg becomes a plus 2, and you need 2 Cl's because that magnesium will give 1 electron away to each of the Mg's, making it MgCl2. So, what does the compound look like when it contains barium and oxygen? Barium is plus 2. It's in column 2. It's plus 2. Oxygen is going to be minus 2 because it's in column 16, needs to gain 2 electrons in order to be stable. So again, we're going to crisscross our charges, drop the positive and the negatives, and in this case we can reduce them because they're both going to be 2's. So when we write this formula, it's BaO because we can reduce these 2 2's, they go away. You want to say most likely Ba2O2, but that's not the correct way to write this formula. You need to reduce this and make it BaO. So here's some practice. I want you to write the formula for sodium bromine, calcium fluorine, and aluminum and oxygen. Pause the video and check this when you get this right. All right, well, welcome back. For sodium bromine, you should have came up with NaBr. Sodium is going to be plus 1, bromine is minus 1. When you crisscross them, you get NaBr. For calcium and fluorine, you should get CaF2. Calcium's in column 2, has 2 valence electrons, so its charge will be plus 2. Fluorine's in column 17, so when it gains that 1 electron, it'll be minus 1. When you crisscross your charges, you get CaF2. Aluminum and oxygen is going to be Al2O3. Aluminum is plus 3, oxygen's minus 2. Crisscross, drop your positive and negatives, and that's it. So let's check your understanding. So write the formula for the compound containing calcium and oxygen. We're going to talk about this one tomorrow in class, but I want you to try it. So what about if you have to write ionic formulas containing polyatomic ions? Now remember, those polyatomic ions are the ones that have both ionic and covalent bonds within them. So you're going to do the same thing as the ionic formulas. Never change the polyatomic ion. If there's more than one polyatomic, put it in parentheses followed by the subscript. So you're not going to make any changes to the polyatomic ion itself. So we're going to combine ammonium the ion with chlorine. So the ammonium ion looks like this, NH4 plus 1. Where did I get this? It's in your reference packet. Remember that table we referred to when we talked about polyatomic ions? You're going to need this for this section. And then chlorine is minus 1. So again, we are going to crisscross our charges only. And then we are going to write our formula. So NH4Cl. Since you only need one NH4 and one Cl, nothing has to be written in parentheses. Let's look at another one. Let's look at lithium with the carbonate ion. So lithium is Li plus 1. The carbonate ion is CO3 minus 2. We are going to crisscross our charges. And then when we do that, we come up with Li2CO3. Now this 3 is from the carbonate ion. See how it's here already? We do not change that. That stays the same. The only thing that changes is the 2 and the 1 get crisscrossed. What about calcium and the hydroxide ion? This one's easy and it often gets students very confused, so let's practice. Calcium is in column 2, so it's going to be a plus 2. The hydroxide ion is OH minus 1. Now, again, we're going to crisscross our charges. Now, since we are crisscrossing with a 2 and a 1, when we write our formula, this is what's going to look like. That OH has to be in parentheses because that 2 is going to go around the OH as a whole. So, for practice, I want you to do magnesium and the hydroxide ion and potassium and the sulfate ion. Pause the video. We'll come back and check this. Welcome back. What'd you get? Magnesium and the hydroxide ion. So magnesium and hydroxide, you should have gotten MgOH2. Very similar to the calcium hydroxide ion example that we just did a slide ago. Remember, magnesium is in column 2, so it's going to be plus 2. The hydroxide ion is minus 1. So when you crisscross your charges, that 2 from the magnesium needs to go outside the entire hydroxide ion. Now let's look at potassium and the sulfate. This one's very easy, K2SO4. Now let's look at check your understanding. So write the formula for the compound containing calcium and the nitrate ion. We're going to answer this one in class tomorrow.